Hello everyone, welcome to this video where we are required to solve the following direct proportion question, where the frequency f of a note produced by a string is proportional to the square root of the tension, T newtons of a string. When the tension is 64 Newton, the string produces a note with a frequency of 360 Hz. So, although the question did not specifically use the word direct, but it is understood that proportional means direct proportion, and from here I can then apply the correct equation related to direct proportion, y equals to kx, whereby this k in this question is f and the x is the square root of t. That means instead of writing y for this particular question, I will have to use f. And for this x is actually square root t. So to solve part A, find an equation connecting f and t. Well, step 1, we have successfully applied it to the direct proportion equation. Color code it. Then, take note, for 360 degrees Hertz, the tension is 64 Newton. And from these two values, when we substitute in, that's where we can find the value of k. In case you might be wondering, should we use the negative root? Nope, because for tension, it is a force and we don't have negative force. Okay, so it is understood again that we are dealing with this positive root. So from here, we can then slowly solve for k. Square root 64 is 8, and therefore I'm going to divide by 8 on both sides, so that I will eventually get the following value of k, where k is equals to 45. And the moment I have 45 as k, I can then write the equation. So the answer would be f is equals to 45 multiplied by the square root of t. And with this equation, I can then find the tension for where the frequency is 540. Okay, so I'm going to substitute f as 540 equals to 45 multiplied by the square root of t. So again, color code it so it's easier for you to see. So from here, I can then continue to solve for it by dividing by 45 on both sides. And this will give me a value of 12. And therefore, I just need to square both sides. And I found the value of T, the tension, which is 144. Okay. Let's move on to part C. Part C gives us the ratio of the frequencies of two identical strings. I'm going to name them A and B, whereby the frequency of A is 2 times that of B. Find the ratio of the tensions of A and B. So I'm going to go back to here and I will need this equation. And I'm going to make T the subject since we are talking about tensions. All right. So I'm going to have 45 divided by 45. So that I will have a F over 45 is equals to the square root of T. And of course, I'm going to square both sides. So that eventually I will have my T as F over 45 square. And this is important. Okay, we set that aside first. Because the next thing is to now make use of, we are going to identify or at least let us have the frequency for two different strings, A and B. So from here, the frequency of A is to B is 2 is to 1, which means that A is 2 units, B is 1 unit, right? So logically, you need to take note that the frequency of A is 2 times of the frequency of B. And from here, now let's look at TA. Tension A is to tension B. And how will we work this out? Well, so for tension A, notice that I can going to make use of this F over 45. So now for tension A, I'm going to write F as frequency for A over 45 bracket square, yeah, is to frequency of B over 45 bracket square. And then let's see. Remember, we realized that this frequency of A is actually 2 times of frequency of B. So Mr. Tan is going to replace or substitute frequency of A as 2 times of frequency of B as shown here. And there's a reason for that, okay? You will later on see why Mr. Tan did this intentionally, alright? So now, our job now is to further simplify these expressions lah, huh? So, 2 times frequency B square over 45 square. The other side I also replicate that. Then for my next step, for those who might wonder, I'm going to break it down further, okay? 2 frequency B bracket square is actually 2 frequency times 2 frequency. And that's why later on you will see it as 4 frequency of B square. And that's where we will suddenly see and understood why Mr. Tan chose to write frequency of A in terms of frequency of B. And from here, let's refresh our memories. Previously, we learned how. So Mr. Tan is going to multiply 45 square on both sides and divide by frequency B square, the square of frequency B on both sides. And when that happens, also take note that there's a 1 down there. And at this moment, we can then see the final answer, the ratio between the tensions of A and B, 4:1. Alright, with that, we have come to the end of this video. If you like this video, do give it a thumbs up. Thank you for watching. Have a nice day.